industry and university. It's a good ecosystem for success, right? If you're looking at, just look at our progress of the digital maturity in Bharat, okay? When we started way back in 1999, 96, when our first commercial IT engagements have started, I think I am of that generation, we used to have that Y2K problem, right? It started with level 4 support, right? We started with that. And I think thanks for all this TCS, Infosys and Wipro of this world, which took us from the level 4 support to the level 3, where we used to own the application development, right? And they have really moved the needle fast. The biggest identity for India has been come there because of the volume of work we did as a application development. And if you look at level 2, it's basically the platforms, right? I think we should all be very proud of what we have built with respect to Aadhaar, UPI, ONDC, the public population scale platforms, extremely well engineered. Day to day, they run billions of transactions, right? And even if you look in the private space, Swiggy, Ola, these are all home-built Indian companies who have shown to the world that India can develop a population scale IT systems or digital systems. Yeah. What probably we are currently lacking was on the foundational tech, operating systems, core AI modules and these things. Probably this is where academia, it's always academia can bring without any commercial constraints the new ideas that you could bring around and we could help to industrialize them, right? Yeah. So this is what we are looking at. So I see it's basically a knowledge and practice-based maturity that will take us there. Thank you very much.
I now call Dr. Shaina ma'am to felicitate sir. I also call Ramesh sir on the stage, please. Sir, yeah. I call Bondu sir to felicitate sir. Shaina ma'am can felicitate Vamshi sir. Dr. Bondu sir to felicitate Dr. Ramesh sir. Thank you, sir. I now request Ramesh sir to take over.
Okay, so this session probably would focus on, actually I have our time? Okay, so what we'll do is we'll quickly see how we can implement AR, VR techniques quickly. Demonstration wise, my team will take over. I will see to it that the connect with what previous session we had will do with this session. Can we quickly start? We'll see how we can build a AR, VR application. Probably we'll start with AR and then complete that with VR. We'll see how we can deploy that in the mobile phones what you have. Unity has a platform where you can build this.
Thank you. It was really nice.
Okay, so in the morning session, probably we saw the foundations required for understanding this AR VR. CLEON, can you play that video? So in this session, we will see how we can create this particular application which you are seeing. Can you tell me whether this is a markerless or markered AR application? It's a marker-based AR application because we are trying to put a marker and then trying to visualize how it looks like. So if you can do this in your mobile phones and put your 3D models, that's where we'll enable an AR application by itself, right? So if you want to make this VR, then the whole environment which is capturing also matters. So down the line in half an hour, we'll see how we can create this application quickly. So Unity's basics, probably tomorrow Sindhu ma'am will cover. I'm not going into details of VR because specifically on time, plus this AR application which is not being covered later. So we'll do Unity based AR application that we are looking forward for next half an hour. So CLEON, can you start? Either talk there. So let me introduce CLEON, who is a part of my team. We have a student ecosystem for engineered data at KLE Tech, and this ecosystem talks about how do we create engineered data, and he assists us in a greater way into how AR, VR applications can be deployed on device. And he's a application developer. He's a Bachelor of Computer Application student, and who has been working with us since 3 years, contributed into many projects with Samsung Research as well, and he's leading that AR, VR team. So he will show you how these applications can be built quickly with the foundations which you have seen. Right? So there are 3 elements basically which we saw. One is the object, the viewer, and the light source which we want to create in the morning session. Similarly, how we can create that in Unity and then deploy it through the platform.
So first of all, what we'll do is we'll start by installing Unity. We can, what I've opened here right now is the Unity Hub. That is where I can control the different versions of Unity that are available to me. So for today's project, what I'm going to use is Unity 2021, because that is like a long-term support version of Unity. And most of the bugs that are going to be, what come up bugs in Unity are normally not available in this long-term version support. There's more support here. Bugs are all ironed out. So we'll start by putting a new project. I'll choose in the 2021 version of Unity. So first we'll start by naming the project. I'll just name it AR app, okay? Now here we'll have to choose one of the templates that we want, okay? So I'm going to just go with Universal 3D because an AR is going to be a 3D app. So we'll skip the 2D, go directly into 3D.
Okay, it's audible to all? Yeah, so the reason we choose Unity is because a lot of tools, 3D tools which does that, but Unity has a lot of support over the years. Okay, so you have a lot of documentations to learn and a lot of, as we saw Bosch uses Unity, it's used by industry people a lot. Okay, so that's the main reason we choose Unity. There are other tools also. Okay, so as we have doing Unity, there is one major thing we have to understand is the universal rendering engine. Okay, all 3D tools have their own engines. Okay, if you develop some game in a particular different engine, yeah, that engine should be compatible with other tool also. Okay. So if it has to be compatible with all the tools, there is something called universal rendering engine, which it means that any game built in that rendering pipeline is supported by all tools. So if you are developing something, make sure that it is being supported by the pipeline, the universal rendering pipeline. Okay. And one major issue, what I can see from Unity is that there are no backward compatibility. If you build a game in particular version, you cannot have it 2 years back project. Okay, you cannot import and run it because of dependency issues and development software codes. Okay. Yeah. No. Reverse is also because there is a limitation of that rendering engine. That's what makes it hard. Some are, it tries to convert the projects, but not, we cannot assure 100% the project gets converted. So what basically happens every time is it asks for the version. Any project which you download, okay, is obviously is in the past. Okay, so if you're downloading some project which is of 2022, it's going to convert it to 2023 version and then run it. That's what happens basically. Okay. Okay. We have a basic view. I'll just introduce you to the tool. Okay. I think CLEON will just hover the cursors to show what those panes mean, the different panes. Okay. We'll just get familiarized with the tool first and then go ahead and have to deploy. Okay. So at the bottom here, we have something called project pane. It's a project view. Okay. Any folders, the project files, okay, are being loaded here. All the folder structure comes here. Okay. In this project pane. And there is something called hierarchical pane. Okay. Where there is actually, there's a difference between project and hierarchy pane. The hierarchy pane actually holds the game objects. Okay, objects in the sense the actual 3D objects what are there in the scene. Okay, so the folder structure comes here and the actual 3D objects. Mic issues. I hope my voice is audible till the end. Yeah. Okay, so we have two objects here. There's something, two game objects presented there. Okay, it's just an empty project. We don't have anything loaded. Okay, I think in Ramesh's session we saw three main components. Okay, we have object, okay, viewer, and the light source. Okay, the same goes here. We don't have an object yet, but we have a camera. Okay, that's where the camera is. we'll add some objects, so you'll usually see the perspective and orthographic view. Okay, so there are two things. One is the main camera. So this is the actual view. What's the what light has been shed to the actual camera, so you can see those points. Okay, only that particular pane, what that particular angle is visible. Okay, so anything up outside from the view is not visible. Okay, and there's something called light here. That is nothing but the light source. If we turn off the light, it's as sure as there's nothing visible to us. Okay. This is how it looks without the light.
And this with the light.
Okay, this is how. So that they see how it looks. Okay, we've added one basic object which are usually available in the assets. Okay. You can have it globally searched in Unity assets. There's a particular source from Unity. It's called Unity assets. You can look for some pre-made prefabs. It's called prefab objects which you can import. Okay. There are free as well as paid, so you can choose from them. We've added Jupyter here. Okay. In the actual virtual world. Okay.
But
so
I'm not seeing that in the main memory. Can you see what is he doing? He's doing those transformations, right? Which you saw in the morning. Transforming your view. He's not transforming the object. He's transforming the view sometimes. Sometimes he's going back to the object and transforming. Both transformations can happen. Like my camera also can move. My object also can move. It depends. If it is really a Hanuman, I can scale it. But if I want to make myself bigger, I need to bring the camera here because I don't have the ability to become larger than what I am.
So I guess on the bottom right corner over there, you can see it's called main camera over there. So you can see there is nothing being shown on the main camera, but you can see Jupyter is placed over there. Now what is happening is you can see those two white lines over there. That is what the camera is actually seeing. So unless I put Jupyter in a position where it's in front of the camera, then we won't see it in the view. So once I pull Jupyter or pull the camera back, then you can see that the Jupyter is being visible to the main camera. So it's being rendered into the scene.
So I think in the earlier session, Ramesh sir said that viewing angle is a problem actually. Okay, unless and until the object is in the viewing pane, the object is not visible also. Okay, the whole world what we are looking is in a 360 degree. Only that's the reason we can see the Jupyter. Unless and until it is put in front of the camera, the object is not visible. Okay.
We call it a viewing frustum. Okay, there are two types of viewing frustums. One is perspective, one is parallel. Right? So orthographic. So by seeing those projectors, can you tell me whether it's in a perspective view or a orthographic view? Remember, always in orthographic view, the projectors do not go inside at a point. Okay? So in a parallel projection, the projectors remains parallel.
So this one is orthographic view, so there's nothing here. In the perspective view, you can see that there's a slight, the actual curve of the earth, like the border, right? It's in the planar, it's in the linear thing. When it's in orthographic. In perspective, it gets curved a bit because there's a different perspective. Okay. So this is one. So usually in Unity, you have to usually have to run this. So to get how it in the play mode. Okay, this is called usually play mode. So this is what I get. We have not done anything. We just started a Jupyter and just displaying. Okay. Any questions still here? Because I'm just going to pace up and yeah. The one which I'm displaying now, this is perspective. Yeah. The views we can change is in the outside of the play mode. Okay. Here. There is no depth at all. Just like everything is at the same distance. You cannot, if I see the DOC University from orthographic view, I cannot tell how large it is or how wide it is. I can have only one. Move it, the object should go smaller. Object will not be visible at infinity or at point zero. That's called a null point, vanishing point. It depends, sir. Generally, it's OBJ, but it supports large amount of format. We have also conditionally 3D. It's not a 3D image. It's a model, 3D model. Okay, there are different formats. There's something called FBX also, which has the texture of the whole 3D object. Open source usually use .obj. It's an object file. There's something called again point cloud. There are different mesh. There are different parts. There are different types. It depends upon the use case. Okay. So the globe which you saw has a texture of Jupyter on it. It's an actual normal circular 3D one sphere, and then there is a texture. That's how it is. Okay. So I have, I think we had mailed some files over the email required. Okay. So this is just to understand the tool. Okay. This is a ready-made package available from Unity itself. Okay, which tells you how to use the tool. So, okay, see here, the different objects, okay, as I said, the left pane is for hierarchy pane. If I want to go for any particular object, okay, I'll just select the game objects. So this is objects, this is tunnel, this is the running, this is stairs, okay, and there is something called the player. Okay. So yeah, I think you'll get a better view it here. This is orthographic and this is perspective. I think 1 minute. Okay, see, now in orthographic view, this is all simple. Now when I go to perspective, this changes. You can see things converging at one point, but still not converging. Basic example for you to imagine is the train rails which are there tends to converge but never converge at the infinity point. That's how you can imagine. Okay. So I think now you're familiar with the viewpoints. Okay. So now this is how there's a robot here. I'm here. Okay. So I'm using my right click, okay, right button to view. Okay. There's something called viewing mode. Okay. I can move around the object using WASD. W is to go forward, S is to backward, A is left, and D. Okay. Q and E to go up and down. Just if I want to see the world around me. Okay. This is still in play mode and not the actual, I've not started the play. Okay. So, okay. Now I'll just run this. So if you're thinking how these objects are loaded, there are different objects put up here and set it up. That's it. Okay. So now it's in a play mode. Okay. I'm using my arrow keys to move around. Shift to run. So obviously there are scripts written in the backend to program these things. It is not just the objects. There is some coding also. Okay. So now. Okay, now there's a star there, okay, which the robot has to capture to get a particular points, okay, a reward. Now what I'll do is I'll try to run and try to catch this star. But this particular now program doesn't allow you because the star is too far. Okay, so what we're going to do is just stop the game. Okay, what I have to do is the star is too far. Okay, now I have to apply transformations to move it nearer because it's too far. See, even if I try to jump from here, I can just go to the first here. I cannot just move so long. Okay, else I have to modify my robots to actually jump there, which is not human. It is not robot. Okay, what I'll do is I'll just click on the object, star. You can also go through the whole world to toggle between those, which I said in this way. So you can go around. If you directly want to go to the object, just click on the game object, double click, and here we are. Okay, now there is something called transform here. Okay, now I have to move this star. Okay, I'll try to show other transformation also. See, now this is one transformation, which I can see the whole star changing its scale. Okay, this is okay. This is rotating. Okay, and now this is actually moving the star. This is what we want. Okay, so I'll just put it to 5. I usually know what is the coordinates, just I'm putting it at 5, but you can play around to know actually the coordinates. Okay, so this is the same as the your role and this one, transformation speech. Okay, so I'm just going to run that. Okay. Now I'll try to go and win the star. Okay. This is sound, but I'm not getting the sound here. So this is how you move around in the game. Okay. This is, I think now you're familiar with the tool. Okay. These are very basic. Okay, if you want to later explore the tool, the zip file which is provided as Unity Essentials, there is something called prefabs. Okay, the different categories. Okay, I'll just go to objects. Okay, so this is a mug. Okay, the different prefabs which you can explore later. Because of time constraint, we will not be able to cover all those. Okay, these are ready-mades, or you can do it from scratch. Okay, it's left to you. If you become either a UX designer or a Unity object designer, you can do that. Or if you are a programmer, you get to code those tools using those prefabs. Okay, so I'll leave it this folder to you people to explore later. Okay, but the settings and the tools remain the same. So there is project pane, hierarchy pane, the scene, and there is something called inspector where you can change the properties of the object. I hope we are clear till here and move to the AR development stage. Okay. Okay. I'll show you a different environment. It's a different way. Oh, this is how it looks. Okay. I think here. Okay, if I now when I play mode, this is actually rendering. But at the same time, you need such particular hardware to render. I mean, you need a bit of high graphics depend upon the object what you're loading. Okay, if you're loading too many objects, you need graphics to actually render it. So in the same way, if you're trying to put a lot of lights, okay, a lot of textures, it's going to take a lot of time to render. This is happening fast because there's only one light source and the prefab actually has minimal properties. Okay, minimal properties in the sense, if I put my face, it doesn't look like a face. You just know they're old 90s games.
the games which are now, which you have Vice City, GTA, which are come now, okay, have a lot of good properties, okay, meaning that it takes a lot of time to render because it has a lot of properties. Here the properties are less because it's a basic object. Okay. ಇದು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀವಿ ಯಾರು ಇಲ್ಲ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ ಮಾಡ್ತೀವಿ ಇಲ್ಲೇ ಮಾಡ್ತೀವಿ ಮಾಡ್ತೀವಿ So now we are going to deploy this whole Jupyter object in an AR world. Okay, it's the same marker base. Whenever it sees the marker, the actual object is projected.
Yes, sir. So starting with the AR development, first what we'll do is we'll set up our AR scene. So there are some prerequisites that are required to build an app or deploy an app as an AR application on your smartphones, right? So first we'll start by going to Window and going to a package manager. That will help us install the packages that are required for this development. I'll go into Unity registry and I'll search in the search bar, I'll search for AR. We'll require two main libraries here, okay? So one will be the main AR foundation that is provided by Unity. So we'll start by installing that. Along with, depending on if you are using an iPhone or an Android, we will go with AR Core if it's an Android phone or AR Kit for iPhones. Those are again provided by their own developers, that is the Apple team or from Google for Android, for the AR to run properly on your smartphones.
So now what happens is Unity is an engine. It's going to render the system, the objects in this machine itself. Okay. Now you need some bridge, some connection to actually deploy it in the phones. It's like a translator between that for what you want to do with the operating system. This AR kit and AR, what is there? The foundations. Okay. They are for, one is separate for Android, one is separate for iOS. So it's own built by them. That's acts as a bridge. So if you have used Android Studio, okay, to deploy apps, Android Studio is a bridge here, but only the packages are used to deploy from the Unity. This is universal pipeline. It holds good for any tools. There is engine, there is a rendering engine, there is a bridge, and then there is the edge device. Okay, it's either Android or iOS. So for iOS, there are a lot of steps to be done. I think it's mailed over the document.
Yeah, so now we are done with installing both the AR Foundation and the AR Core XR plugin. So you can see there's a tick mark on both of them. That means they're installed.
Okay. So AR Core is actually for Android. This is installed. We have an Android phone here. Just putting in. One main thing to notice is we cannot deploy an app from Windows to an iPhone. It's not possible. From a Mac, you can deploy it for both Android and Windows. The iPhone has a limitation for it has to be delivered from the Mac itself because they don't have a drivers. So here we just have AR Core installed. AR Kit is for the Apples. It is going to usually take us some time to save the audience's time. We have already installed it.
So one difference that we do from VR to VR is that the environment what we are putting in is being captured from a camera. That's the difference. The object, interaction, everything remains same as VR, but just that the environment is captured through the camera, and camera is enabled to understand the 3D world in which it is. So it is understanding some markers, some key points, so that the particular object enters in there. So it is creating its own environment through the camera to understand this is the world. It's not virtual, the world is real, the object is virtual.
Yeah, so now that we have installed both the AR Foundation and AR Core, if we right click onto our hierarchy, right, we'll see an XR over here. Okay, now we'll require two main components from this. One is the AR Session Origin, that will be our AR camera. Okay, because we can't use the main camera here because it's meant for desktop use cases. The difference between a main camera and an AR Session Origin is that AR Session Origin will take the coordinates of our camera and position the camera in the real world for AR use cases. So what I'll do here is I'll delete the main camera because we already have our AR Session Origin here, and we'll Here what I'll do is I'll set the AR section origin to 0, 0, 0, so that we get our origin from the point we start and our camera doesn't go somewhere else. All right. Now along with this, we will actually require some sort of 3D model, right? That we have to view in, that we want to view in AR. So for that, what I have already done is gone into the Unity asset store, which I can go by pressing window and pressing asset store over here. Okay. Once the asset store, it'll open online. I'll go there, it'll open here, and I can, I don't have net right now, but we can download any sort of assets from the game store there. So
You can use the assets from the prefabs which are given from the Unity Essentials. That works too. Also, you need not worry about the AR session origin and the camera put up here. There was another folder zip file which was having for AR template. That consists this actual codes. It's already there. You just have to run it and you'll get the code.
So what I'll do now is I'll go into prefabs again and I'll drag in Jupiter. Okay, this is a Jupiter planet onto the scene. Okay, for this also again I'll put the coordinates to 0, 0, 0, so it aligns with my camera. Okay. So once I go into AR session origin, you can see that the Jupiter is over here. Just a minute. So I'll move it in front of the camera again. So same as what we did with the same thing. So that the Jupiter is in front of our camera. All right.
If you click on the object, it gives those dimensions, so you can know where is it looking. Because you have deleted the camera, you don't get that perceptive view. Okay, but with this axis, you can tell it's looking up or down. What axis? Usually, if you select the object, you get that. So you have this XYZ. So if you really want to rotate the object, there is some tool here. I think yes. Okay, you have this, so you can change the whole. So the same goes here. If I actually want to, I can rotate the whole object. Okay.
So the Jupiter is still not in front of the camera, so I'll just move it towards the camera now. So we can check by moving into our game tab over there, right? That will show us a pre-rendered view of how it might look. So this is how it will look. The scene is black because the scene will be replaced by what? Our actual environment. Okay. So
that is actually being created by the AR session. The AR session is the actual camera. Okay. So that's why it's giving black. If I actually add the, we deleted the camera before, right? If the camera was there, it would not be black. Because it's only AR session, it is black because the real world is here and nothing else.
So I'll just position, so I can again position the camera wherever so that it's centered. Okay. Now one more thing what we'll have to do is, as you said, scale is a very important factor in this. Now what happens here is, this is true to scale. So if, for example, you all can see the scale for the Jupiter is 1 by 1 by 1, right? The scale over here. In the inspector window. Okay. Now this represents 1 meter by 1 meter by 1 meter. So the Jupiter is going to be 1 meter long if I end up using it here in the real space, which is very big for our case. So what I'll do is, divided by 10, I'll make it 0.1. That will become how much? It will become 10 centimeters, which is much more manageable for me to show in VR, in AR.
You can play with this by actually deploying. You will actually get to know the size. So you can then come back and change. Because you already know beforehand it's going to be large, you're just changing the scale. You can just run as it is and know what it is. Because in
fundamentals of computer vision, right? Unity uses this KLE. Okay? So just reading you will understand what to do. Without knowing those fundamentals, if you start learning Unity, it's really difficult.
because we know the foundations of vision, we know how to use the tool itself. There's nothing new to learn for us. In usage wise, we have to learn, But understanding the tool and those perspectives, those geometries, we usually get it.
Next now, as sir said, it's going to be a tracked AR. So we need a marker for that. So a marker can be any sort of image. So what I will do is just go to the internet and download a Jupyter image, which I've already done, okay? So this Jupyter image, I'll drag it down into my project file over here, okay? So it comes here.
Here we are actually taking the custom marker. As I said, there is also the marker representing the whole Unity template. You have default markers there, we can use them also. They are just
markers or something. They are calibrated. They will never go wrong. These images can go wrong sometimes.
Yeah.
Okay. Arco markers are like QR codes. Okay. QR code is arco marker.
So can anyone try to relate from the previous session? Why is this what is this marker doing now? What is this main thing? What is it used here, marker?
Why are markers used? Yes, it's a identification of the space. It's giving you information how the world is all about. Because I know the dimension of the marker, I can find and say relate that particular Jupyter to that particular marker.
Now, for example, if I don't have a marker, I have an object. This whole lecture on where should the Jupyter be placed? That's a question mark. If I have a marker, I tell this is the plane. This is X, Y, and Z. That's what it. That X, Y, Z what we have tells that this is a camera and this is where the object has to be placed.
Scale becomes a problem, position becomes a problem. Both are challenging.
Now what we'll do is, for our AR session origin, that's our cell phone, to understand a marker, we'll need to add a component here in the inspector. What an inspector tab does is shows what components, what scripts or codes are being used for that particular object within our scene. Okay, so if I click on session origin, I'll get an inspector for itself. So I'll just add a component here and I'll add an AR tracked image manager. What this does is gives me a place to put in my image that has to be tracked and an AR object to be placed, along with another one tracked image prefab. That is our actual model, 3D model that has to be placed there. So what this component basically does is searches for the tracker or the marker, and once it finds the marker, it will render the 3D model onto the marker. Okay?
So don't worry about the steps if they are too fast, because the time constraint we are going fast. You can find the same tutorials online. You can get it from Unity has its own courses, learn.unity.com. But what we are trying to do here is the Unity course will just tell you how to use the tool. It doesn't give the relations with what actually the 3D world is and what is the perception. You don't get the relation. It's just like you know the tool and you do not know how it's working. Okay. Because we have a session before and now we're trying to read those things. How is this applicable and how do you go ahead?
So what to read from online also is a challenge. So Ushin, so in the morning session I have consolidated all that work to just an hour so that you understand the terminologies of Unity.
So it's like the pilot knows how to drive airplane, but he doesn't know the mechanics. It's something like that.
So what I'll do now is take the Jupyter image and put it into our serialized library here. Okay. What this does is it gives, wait just a minute. So first what I'll need to do is create a XR template here. So I'll add a reference image library here, okay? What this does is acts as a reference image that is a carrier to the code. It's another plug and play component.
So I have a marker, okay. I want to attach that marker to a reference library, that's it. I have a marker, but there is no relation between the camera and the actual object. I just have the image, okay, as a marker. Now I have to connect that with the actual reference library. That will tell me that this is the actual marker and this is what you have to look for.
So it's like object detector in that space.
So I'll just press add image and then drag Jupyter into
Now
this folder.
there is a connection between that, the library and the actual marker. Here the marker is same as the actual object. You can have different markers also.
Okay, so now I'll again press on AR session origin, which will give me my tracked image manager. and I'll take my reference image and I'll drag and drop it over here. So it goes and sits into the library. So now it knows what image to look for. Now what we'll do is, as you see, we have placed our Jupyter over here, right? I'll just drag the Jupyter from my hierarchy into my asset folder again. Okay, what this does is creates a prefab. Now why is this called a prefab? I'll let you all know. Is a prefab is prefabricated. That means I'll take my 3D model, give it all the transformations that are required for the project, and then all those transformations are now set. Okay, so I wanted it to be 10 centimeters and I wanted it to be at a certain position on the marker itself. So I set those values and I drag and drop it here, so it becomes a prefab for me. If I don't do it, then I'll have problems with the scaling issues later. It might be very big depending on the scenario. This makes it very standardized.
See, the difference is the person who is actually creating those 3D objects, okay, he doesn't know where it is being used for. So he creates the actual 3D object in a full-fledged 100%. Now, taking that whole 3D object, okay, I want to load it as a small version or a larger one, I have to design it. So after designing that, it's called a prefab.
Now again, I'll go back into my AR session origin and take the prefab that I just created and I'll drag and drop it into the game object over here. Okay. Now once I've put it here, I have no longer use for the Jupyter that is there in my hierarchy. Now why is that? Now if you see, if I go into my game scene, the Jupyter is already rendered, but I don't want that. I want the Jupyter to be rendered after the marker is shown. So that is handled by what? This AR tracked image manager. So what I can do is just delete the Jupyter from my scene for now.
So now you can see there is no Jupyter here. If I add a Jupyter now in the actual world, okay, before loading, before actually identifying the marker, is already Jupyter. Okay, the game world which we have created.
Which I am keeping in the real world versus one render, both will be there in the scene, which I don't want actually.
So that's the reason I'm deleting it from the virtual world. I want it to appear only when there is a reference image form. That's why you can't see any the actual object here now. So as I said, you can just make those trial and errors. If you add those images and you see what is the difference. You actually get a globe as well as once you identify, you get another Jupyter.
So now that's it for the setup part.
So we'll demonstrate how does it look like in your mobile phones. You can quickly do this. But I am aware that at 4:30 we will go. So under 2 minutes we will demonstrate. Any queries till now? I know it's pretty fast. Any queries we have? Yes, you can. But the format in which you say need to be supported by you.
There are conversion ways which you can convert the actual OBJ to a different format and load it here. Yeah, it's an OBJ. You will get an OBJ format. But also export it as FBX object. This is what. Any object done in Blender can be loaded.
Yes, Render Studio is very similar to this. Platform build is same.
We'll try to screencast the actual phone because it's going to show it to me and not to you people. It's fine.
So after this setup, right? So the last final step will be just going into the file, go on to build settings. Okay. Here I just switch to Android and I press build and run. What? Yeah. So check.
At the first time, in the initial stage, you will have to select switch platform. Okay. It's going to take some time to switch the platform to Android because it was now rendering in the Windows version. Okay. So now the platform is changed. So it takes few minutes. Okay. It's one time.
So I guess the previous speaker also spoke about how Unity is using to switch between different platforms, and there is minimal changes that is required to switch between the different platforms for different sorts of deployments.
to have this Android and iOS option, you will have to install those libraries, which was it's there in the documentation. Just follow them and install those respective libraries. There's nothing more to do with those libraries. You just have to install them. Nothing need to be coded explicitly.
See, with ChatGPT's invent, a lot of coders are not in the job. Right? So coding is done by ChatGPT, but what knowledge does ChatGPT? So it's an enabler rather than a job seeker with rest. So using ChatGPT in the right way, using these LLM tools in the right way also enables you to do on the They are pretty straightforward. We can send, but what happens is these keep evolving every day. So unless you make their hands dirty, it's like Lata Mangeshkar sharing songs with you. Unless I singing like that.
We're trying to put those online tutorials to our knowledge so that you can understand any other future developments. It's not that a new tool comes and we don't know the tool. You know the fundamentals and you know the basic tool now. So even if there is new development ahead, after 5 years, you know the basic knowledge. So you know that this is perspective zoom only and there is orthographic and this is the camera and this is daylight.
Those fundamentals don't change.
Yeah. That remains same over throughout all the tools, not just Unity. You need those basic fundamentals, the object, the source and the camera.
Yeah, so now we are switched to the Android platform. So all we need to do is connect a USB cable to the smartphone and press build and run. For this, you will have to enable USB debugging on your smartphone through developer options. Okay. Huh?
Yeah, it takes a minute. It's already built in our phone. Okay. I'll just show how it looks there.
So we have already built the app already on the phone previously.
When if I try to build again, it's going to replace the app. Okay. So there are again few settings to be done. You will have to enable developer options, USB debugging in Android 2 to get it running. Okay. So just to know that this Android, there are not just Android and iOS. There is TV platforms. There is Google TV. Different platforms where you can deploy them.
Yeah, so as you can see, so there is AR Jupyter app installed on my phone. It will come on your phones also just like this. So you all can see it's a normal.
Okay, now the Jupyter which you saw is because we had this Jupyter wantedly put up there. It's in the 3D world. I can show you here. It's inside. Okay, we have this Jupyter here. That's why you have already Jupyter loaded. If I delete this, you get a Jupyter only when it is matched, when you find the identifier. So that's why.
So now this one, you don't have Jupyter anywhere.
And another version which we had deleted. Okay.
So what I'll do is I'll open the image identifier and scan it. So once it's scanned, you can see right in front of the.
Remember when we positioned the actual Jupyter ahead of the camera. Okay, if you keep it at the same source, the Jupyter will just load it there itself. It's left for the developer to decide where you want to view it. Now you can see it's a very small Jupyter. So in the same way, you can actually load the whole solar system also. Okay. Okay. again you will have to write a script for it. So again it's going to take a time. Again you'll have to load the actual scripts which are already written. So go writing is going to take time. Okay. So you can actually make those objects interactive.
So I hope this convinces you on the capabilities of devices and governance right? So now you will build your own user on your own. Get back to the uses we have. You can have one or two more pages and one more animated
I think we are right on time. It's 4:30. Okay. So we can usually main application is you can use it for